Right, today I'll review adding and subtracting vectors that are at angles to each other. This concept is more of a challenge. We're going to talk about it in class, but this is just for review. I'll just call it adding and subtracting vectors, right? Again, we talked about why I really like having the graph paper that has us measure stuff, so I'm setting that. And I'm going to work through these notes with you. Okay, adding and subtracting vectors. Okay, the first one is parallel vectors. Parallel vectors, if they are parallel, so I'm going to say this is a 3 Newton vector because it's 3 squares, and a 5 Newton vector. They're pointing the same direction. You just add them. So the resultant, which we talked about in some classes, is the answer. Is I can't add one too many. 8, there we go, is 8 newtons. Also change the color. Okay. If they oppose each other, so I have 2 newtons of force versus 3 newtons of force, that means they kind of subtract, but pay attention here. That means there's 1 newton of force going in the left direction. Okay, so that's how it'll work. When we get into positive, negative accelerations, you're right, this will be negative, and you would just think along a number line. If you see our number line, it's positive, this side's negative. It's going to kind of work the same way. Okay, vectors, as we learned before, have scalars, meaning there are numbers, and they have direction, meaning they go in a specific direction. Okay, but what about if I have non-parallel vectors? So for example, we'll go with the easy ones. I have something on 1, 2, 3, 4 newtons north, and that is newtons, not north. So this could be an arbitrary direction. It just depends on where you hold the paper. And 4 newtons to the right in this case. Okay, it's at a right angle. So I'll put my right angle symbol in here. Okay. When we calculate this, the first thing you need to realize is the parallelogram rule. What that is just simply the resultant will go the direction that connects the parallelogram. So in this case, I'm going to do my dotted line, dot, 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 dot. I'm going to do a dotted line here. Okay. This indicates, so the resultant should go from corner to corner. It's as simple as that. When you have two people pulling, so if they're pulling at equal forces at a right angle to each other, then your resultant, the movement of the object, if this is a desk or a rolling cart, whatever, it will go this direction. Okay, my sample printout. Okay, so same thing, I'm going to practice this here and I'm going to give you guys copies of this. If I make a parallelogram, so parallelogram is simply just parallel lines. So this one is parallel to this one. This one is parallel to this one. Pulling out some geometry stuff here. Same thing here, parallel, parallel. This one's parallel to this one, parallel, parallel. That just means those are the corresponding angles. Okay, when you do this, the resultant, if I'm pulling, this one's pulling much harder, so side A is pulling harder than side B. So you would venture to guess if this were an object that you were pushing, it would move in this general direction. It moves a little more towards A than it does B because A is pulling harder. Okay, same here. If this is A and this is B, then we're going to angle it this direction. Okay, you can kind of walk through and do that for 3 through 6. This is where people struggle, is 5 and 6, 4, 5, and 6. Parallelogram, you still have to be attentive to being parallel. So here, you think this shouldn't be super hard, but this one needs to be parallel to the bottom. And then this is the line we're dealing with right here. So I need to make this one equally parallel. And get out a ruler and match it. Okay, notice how it turns from a rectangular box like an A to a quadrilateral box, right? There are no right angles and the whole thing tilts. But even still, if we're not pulling at a right angle, you're still going to get this resultant. It gets pulled more towards side A and less towards side B, but on that angle. So make sure you're paying attention to that for 6 and 4. Okay, adding and subtracting vectors. Okay, so that's the base. And if you notice, I'm always labeled this one as A and this one as B. That just makes it easier for me for being consistent because we're going to need to use that. Okay, so the parallelogram rule is just how you determine the direction of a resultant. Okay, it's important to know. Okay, now, we figured out the direction. How do I calculate the magnitude? Okay, this is when this fabulous formula, Pythagorean theorem, shows up. Pythagorean theorem allows you to determine the hypotenuse, which is this. This is also referred to as a hypotenuse. So Pythagorean theorem allows you to determine the hypotenuse I probably spelled this wrong. I'm sorry. Of a right triangle. Notice I said right. So when these weirdos over here, where these are not right triangles, we will not be calculating. We're not going to calculate the number. I don't know what it is. I'm not getting into sine and cosine with you guys this year because that gets into higher level math that we haven't really covered or you haven't covered in algebra. So we will only be calculating for a right triangle. Okay, Pythagorean theorem, what is it? It states a squared plus b squared equals c squared. And now you suddenly know why I was putting b and a up here, right? So now let's start with the easy one that I just drew. If I have 4 and I have 4 newtons, 4 newtons, okay? So if I label this like I was doing before as A and side B, let's plug in our numbers. Please always write the equation first and then fill in the numbers. So 4 squared plus 4 squared equals c squared. I require you to show your steps. So show me this is 16. plus 16 equals c squared. Notice I wrote c squared every time. That's really important that you do that. So 32 newtons, I forgot my units, don't forget that, equals c squared. How the heck do you get rid of the square? So I told you need those calculators with the square root. To cancel out the square, you square root. Now you'd have to pull up a calculator and do that real quick. So the square root of 32 is going to be, bear with me, square root of 32 anytime now. Pardon me. Okay, 6. Give me a moment. Okay. Stop. Oh. 5.6. So, let's say C is equal to 5.6 Newton. So that's my approximate. It's not exact, and we didn't quite follow the form and function of adding. Well, no, we did. There's two. You add these two. You do the math. 16. Now when you add 16 and 16, each have no decimal places. So theoretically, you shouldn't be using the decimal place for significant figures. We are, because the difference between 5 and 6 is important here. So one little caveat here. Okay, so there you go. So if you did another one with a greater distance, each time you're going to plug it into this equation. So when you get back to page 14, I think, here's what I want you to realize. Here would be 4 squared plus 3 squared equals c squared. Okay, this one is tricky. You have to realize that you have to deal with the parallel lines first. So ultimately, once you cancel this out, this will be 5.3 newtons south. And now you can, oh look, it looks pretty similar. Okay, same thing here. You have to cancel these out. This and 3 goes away. This becomes 7 newtons. And look, these are the same. Okay, work through these. This one, these guys are a little more complicated. I will not be putting them on a test. So try this, try through 14, and we're going to talk more about this next time. Oh, you can do parallelogram rule on this. So now you can draw your reverse force arrow. So the next thing you have to realize is that if I skip to this printout, this works the same the opposite way. So you can do a parallelogram this way and this way, and it'll determine what your original forces were. This one and this one. So you can work through that on each of them. So your original force should have been here and here. So if you notice, there's my parallelogram. I'm being hasty because I'm running out of time. So attempt page 14 and 15 on this. Okay, 14 and 15.